All right, let's just go over quickly how you get data into Mark for a robust design. So we're going to click on File, New, and come down here to Robust Design. And like we saw with the closed capture models, there's a whole variety of them. And I will just go over Huggins P and C. That's what you can start out with. But it's easy to switch the data types once you get the data into Mark. So I'll click OK, and I'm going to select the file. I'll do RD Simple 1, just open it. Well, there we go. Okay, and I'll just type in a name here. Now let's just take a look at the file. And there's 15 occasions, 15 capture occasions, and they're divided into 5 primary occasions and 3 secondary occasions. So 5 years, say, and each year 3 trapping events were carried out. So you need to tell Mark how that is entered. So we have 15 capture occasions. We just have the one attribute group. And Mark provides this nice, easy way of reading in robust data, assuming that it's fairly standard in terms of the numbers of occasions. So I'm going to indicate that there's 5 primary occasions, and then it'll say, okay, there's 15 total, 5 primary, so it kind of makes sense that there would be 3 secondary occasions in each primary occasion. It doesn't have to be true. If you missed a day one year, you can just indicate, change that from 3 to 2, for instance. Or if most years there were 4, and then one year there was 3. Again, you can just switch that around depending on the numbers in each. But generally, when you're trying to do this sort of study on small mammals, you try to keep the number of secondary occasions constant within each primary occasion. And then the other thing you can look at to make it sure it assigned it right are the time intervals. And so these indicate the amount of time that's elapsed between each of the capture occasions. And between the secondary capture occasions, you're going to use 0 because you're saying that your capture occasions are so close together that you can make the assumption of a closed population model. And then in this case, say there was a year between each of the primary occasions, then you would put a 1, okay? And notice, of course, these are the intervals. So it's 0, 0, and then 1, 0, 0, 1, and so on. And you only have 14, even though there's 15 occasions. The other thing to consider is a lot of times with small mammal or other studies where we're going out and doing short bursts of trapping and then going out and doing it again, we may do it, in the spring, in the fall, maybe even in the winter, and then in the spring again. So in that case, you would put number of months between each primary occasion into the columns here. And notice that, you're not going to be able to vary this. If it was 3 months in 1 year and 2 months, well, let me think about that. Yeah, no, actually you could. If you're plotting out the interval for each one of the occasions. So if it changes from 3 months to 2 months on occasion, you could enter that in here. And then Mark will keep track of that. And it's important to remember now that the survival estimates that you get between your primary capture occasion is going to be in the units that you use for these intervals. So if you put in months, now you'll be kicking out survival per month. And if you want to standardize that to like annual survival, then you'll have to do the conversion. Okay, so we just hit OK, does the regular thing of bringing in the data. And I just want to look at the PIM matrix here and just go over it. So again, we have a robust model, so we have survival parameters. We have these new gamma parameters for moving in and out of the superpopulation. And then we have our standard closed capture parameters. So this first here, the bottom row, they define as S for survival, okay? And then gamma double prime is the next row, gamma prime is the row after that. And then you get into your capture probabilities for each of the sessions, okay? And then your recapture probabilities, okay? So for primary occasion 1, you will have 3 potential capture probabilities for each of the 3 occasions. For session 2, same thing, 3, 4, 5, okay, because we have our 5 primary occasions. And then you get into your recapture probabilities, and of course there will only be 2 associated with each primary occasion, because you can't have a recapture probability until you've had your initial capture probability. And so you can see, if you capture over a lot of years and maybe you have a bunch of sites where you're doing your captures, very quickly the PIM will become giant. There will be lots and lots of parameters. And one of the big considerations and struggles in the robust design is, how do you simplify that? You're almost never going to really run the most complex models unless you just have this unbelievably robust data set. And so then you have to immediately start thinking, okay, how does it make sense to start constraining these parameters to make a model that's reasonable? All right, that should get you started. Let me just show you one other thing. I think we've gone over this before, but for the different types of robust models, you're going to have to use different data types, and you just come and click on PIM and then change data type, and then it'll give you that same list of designs that we saw earlier, Huggins with heterogeneity, and then at the bottom here would be the Huggins P&C with random effects. Okay. All right, folks, that should do it.